Hello everyone. So today we're going to be covering how to solve a system. In this case we're solving with three linear equations, and I'm going to go over a strategy that I normally teach to my students to tackle these types of problems. Okay, so when it comes to solving system algebraically, you're going to be combining a bunch of the equations to hopefully cancel out some variables and then eventually solve for the value of each variable. So let's start off by numbering each of the equations so that when it comes to writing out the strategies that we're using, we know which equations we're combining. So I'm labeling them 1, 2, and 3, something simple. And when I choose my equations to work with, if possible, I want to choose equations that immediately cancel out variables. Sometimes it might not work out that way, and you might need to multiply the equations to then have them cancel out variables. But in this case, I can see that the y variables definitely cancel out amongst a bunch of the equations. So let me choose two equations to work with. I'm going to choose 1 and 2. And I'm going to add 1 and 2 because 3 plus negative 3 is going to cancel out to 0. So let's do that. So equation 1 plus equation 2, that's going to give me x plus 3y plus 5z equals 45. And then 6x minus 3y plus 2z equals negative 10. Okay, I have x plus 6x, that's 7x. These cancel out. 5 plus 2, that's another 7x. That gives me 35, and we're done with that. Sometimes your numbers can work out where they're all divisible by the same number. So if you want to simplify that, go ahead. I'm going to wait until I come across another equation, and then I'll determine if I need to simplify or not. So I used equation 1 and 2. You can reuse equations as long as it's beneficial, but don't reuse the same equations with each other. So for example, since I use 1 and 2, I'm not going to use 1 and 2 again. I'm going to use some other combination. Here I have x and z as my variables, so whatever combination I use needs to also contain x and z. And luckily for us in this system, if I were to combine 2 and 3 this time, then my y's will cancel out again and I will be left over with x and z. So I'm actually going to add equations 2 and 3 for my second round. Then I'll get 6x minus 3y plus 2z equals negative 10. And then negative 2x plus 3y plus 8z equals 72. Then I combine terms, so that's going to be 4x. These cancel out. That's going to be plus 10z equals, that's going to be 60, that's going to be 62. Yeah, sorry. So now I'm looking at my coefficients of each variable, and I'm seeing that nothing is canceling out. So that means I need to divide out something or multiply something so that I can have a common number to cancel out, or inverse numbers to cancel out. So I'm actually going to simplify this first. And I'm going to divide all these numbers by 7. That will give me x plus z equals 5. And now I have this simplified version, and here I'm going to try and determine which variable I want to cancel out. I'm actually looking at that 4. So what can I add to 4 to make it 0? That's going to be a negative 4. So I'm actually going to multiply this entire thing by negative 4. And this pathway that I'm choosing to simplify my equations can be completely different from any idea that you might have in mind. There's a lot of freedom with how you can carry about simplifying this system, but you want to make sure that whatever you do, you're consistently trying to cross out some variable so that you get your answer. Okay, so now I have negative 4x minus 4z equals negative 20, and I'm going to combine it with these two. Okay, so I have the following. I'm going to add them. I have the following. So negative 4x minus 4z equals negative 20, and then 4x from here plus 10z equals 62, and then the x's cancel out. I have a 6z equals 42, and then if you divide both sides by 6, z equals 7. Okay, and this is good because we have the value of one variable now. Now, what do we do with this answer? Well, we're going to take this single variable and plug it back into one of these, or even this one of these two variable equations. It doesn't make sense to plug it back into the original because there's three variables here, and if we plug this in, we're going to be left with two variables, and that's still going to be an equation that we can't solve yet. So I'm actually going to plug this into this one, since I already simplified it, and that's going to give me, just going to do it right here. So I'm going to take this one, x plus z equals 5, substitute, so x plus 7 equals 5, subtract 7 on both sides. I'm going to get x equals -2. All right, so we're almost there. Now that we have two variables that we've solved for, now we can plug it back into one of the originals. So I always advise just plug these values back into one of the easiest looking ones to plug in. I'm going to choose the first one. You don't have to choose the first one. You can choose whatever you want as long as you're plugging them back in correctly. So x is -2 plus 3y, I don't have anything for that, plus 5 times 7 equals 45. We have -2 plus 3y plus 35 equals 45. And then subtract 35 on both sides. We get -2 plus 3y equals 10. And then we're going to subtract 2 on both sides. Did I do something dumb? Feel like I did. Subtract 10. Oh, sorry. Here it goes. I'm just thinking silly. So yeah, add 2 on both sides. Whoops. Then we have 3y equals 12. Divide both sides by 3, and then y equals 4. Okay, great. So you would think we're done, and we're not. We are not, because you always want to check your values in the system that you have. So what you should do is plug each of these values into the equation, all of them, and make sure they all work. So I'm just going to try out the first one. You guys can do the rest on your own. But this is a very important step to ensure that you've successfully solved for all of the values in your system. So I plugged in the values for the first equation, and they do equal 45, so that's good. That's a check on the first equation. You want to plug them into the last two, see if they work. If they do, then you are officially done solving for the solution of the system. And if you need to write it as a coordinate point, you're going to write it as XYZ form. So it'll be -2, 4, and 7. If they ask you to write it as a coordinate point. If not, then boxing your answers is just as fine. Alright, so that's pretty much it. If you have any questions or comments, leave them in the comment section below. Like, subscribe, and share. And I'll see you guys later. Bye!